Hello, welcome to another video of PiPad Mathematics. I am Professor Lamb, and this video is going to explore the Brainingcamp app, Number Rods, which is the Number Rods app is just a version of or utilizing concepts behind Cuisenaire rods, or often called or sometimes called integer rods or fraction rods. They're known by many different names in the work of Georges Cuisenaire a while back, when he wanted to get his students to understand the concepts behind fractions. Have been things that have been mentioned throughout the decades. In the joint meeting back in 1960 with Jerome Bruner referencing them, all the way up till Marilyn Burns in the 80s till now, when we have online apps that utilize them, and now iPad apps that utilize them. And they're very important. I use them in my classrooms. I use them when I train teachers. This stuff is really cool, and I like it. And there are videos that I've made related to the fractions and the ways that you can model fractions. And now this video is going to be about whole numbers and understanding early number concepts of whole numbers, where you're adding and you're subtracting using these models. So what we have is an exploration into whole number addition. And students, young students, are going to take this rod or take these rods, and they're going to find values for them. Now, if you're dealing with young students, you may want to use a square grid so that they can quickly see when they bring a rod out that yellow is going to equal 5, because they can see that yellow is 1, 2, 3, 4, 5. So it equals 5. And then that black one is going to equal, let's count them up, 1, 2, 3, 4, 5, 6, 7. So that equals 7. And when I have a yellow plus a black, then you can do it a number of ways. You can know that 5 plus 7 gives you 12, or you can line them up and you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equals 12. So 5 plus 7 equals 12. You can also do the black rod and then do the yellow rod and see that 7 plus 5 equals 12. So with your young students, you can have them create mathematical equations and model the commutative property of addition. Very cool, very exciting. I like it. One popular way of doing addition with students and doing addition utilizing these Cuisenaire rods are to make number trains, to where we have a light green rod. And the light green rod can be broken down into 3 white rods, or it can be broken down into a red rod and a white rod. And with order important here, we are going to do a one white rod and 1 red rod. This light green equals 3. It equals 1 plus 1 plus 1. It equals 2 plus 1. It equals 1 plus 2. So you have students make these number trains and then write the mathematical equations or expressions that are modeled by that number train. And they can see the commutative property taking place. You have students come in and do the yellow rod. I'm going to move it over here. The yellow rod can be made up of 5 of the white rods. The yellow rod can be made up of a purple and a white rod, or the white and a purple rod. It can be made up of a light green rod and 2 white rods, a light green rod, let me move this over, the white rod, then the light green rod, then the other white rod, or 2 white rods and the light green rod. Or of course we can do the light green rod and the red rod, or the red rod and the light green rod. We can also do the red and then white, or the red, white, and red, or the last one, the white, red, red. So these are all the different rod trains that you can make for the yellow. And then when you write the words out, or write the number sentences out, we have 1 plus 1 plus 1 plus 1 plus 1. We have 4 plus 1, 1 plus 4, 3 plus 1 plus 1, 1 plus 3 plus 1, 1 plus 1 plus 3, 3 plus 2, 2 plus 3, 2 plus 2 plus 1, 2 plus 1 plus 2, and then 1 plus 2 plus 2. So here are all your numerical expressions that help model or help show what is modeled in our number trains. So this helps students explore the concepts behind addition and subtraction of whole numbers by making these number rods. I'm going to jump over to the no grid real quick, and we can do the same thing with subtraction. We can take our blue rod, which is length 9, and we want to say 9 minus 3. Well, 9 minus 3, if I put a 3 on top of it, then I'm trying to find out what is inside that leftover piece. What is left over after I take the blue rod minus the light green rod, and that's going to give me the dark green. Well, the blue rod is equal to 9, the light green rod is equal to 3, and so what's left over is my 6. So 9 minus 3 equals 6. I can rearrange that, and I can say, what is 9 minus 6? Let me erase, oh dear, equals 6. If I rearrange it, then we have our 9 minus 6 equals 3. We have this kind of fact family type of relationships to where 6 plus 3 equals 9, 3 plus 6 equals 9, 9 minus 3 equals 6, and 9 minus 6 equals 3. So here are your fact families for this model that is modeled right here. There are wonderful numbers of activities that you can utilize with the Cuisenaire rods and whole numbers, and these are just a few. But getting students to see the concepts behind adding and subtracting by using these models is just one way to get the students engaged in the learning process and hopefully get them to retain the knowledge a little bit longer after they've been taught or attempted to learn it. But we all know as teachers of mathematics that the learning is an ongoing process, and we want to build lifelong learners, and we want to get them to think on their own and to be engaged in the learning process. And so using technology like this can help build that engagement and help instill in them an idea of exploration and being that lifelong learner. So I thank you for watching. I'm Professor Lamb, and this is PiPad Mathematics.